Alright, in this video we're going to cover Cartesian products, and I'm going to give you a very formal definition for an ordered pair before we start. And an ordered pair AB is a set that contains the first element as a singleton in that set, and then both elements as a set in that set. Now, this is a definition you would use in later courses for proofs, but I don't want to focus on that right now. Instead, I want to focus on it as you've seen it before. So, for instance, we've seen this ordered pair notation when it comes to graphing in high school. So, for instance, the ordered pair 1, 2 would mean 1 on the x-axis, 2 on the y-axis, and we'd have this point here at 1, 2. For 2, 1, of course, you would go 2 on the x, 1 on the y. You'd end up at this point, 2, 1. And for negative 2, 0, you would go 2 on the x-axis in the left direction, 0 up or down, and you'd end up at negative 2, 0. But just as a very specific way of representing these points in the set definition, let's take 1, 2. So with 1, 2, this would be the set containing 1 as a singleton, and then the set containing 1, 2. And we can see that this is different from 2, 1 because if we do the set notation for 2, 1, what we have is we have the set with the singleton 2 and then the set 2, 1. Now you'll see that, of course, this subset is equivalent to each other, but the first one is not. So that's how we can tell that these are different. And this is good because if we have an ordered pair, we know that 1, 2, and 2, 1 are different, therefore in the set notation it should be different as well. But really, when we talk about these ordered pairs and the Cartesian products, we usually talk about something called the cross product or the Cartesian product, A cross B, and it is a set as well. But it's a set of ordered pairs, and you can imagine if we didn't have ordered pairs, these sets would consist of many, many smaller sets, and it would be very difficult to read. So imagine I have a set X containing 0, 1, and 2, and I have a set Y containing 0 and 1, and I want to find the Cartesian product. Well, that's just the set of ordered pairs where the first element will come from X and the second element will come from Y. So if it's X cross Y, the first element comes from X, the second from Y. If it's Y cross X, then we reverse it. So I'll do the first one very slowly for you. So X cross Y. So this is a set. It's a set of ordered pairs. So in my first ordered pair, I will have the first element come from X, and the first thing I see in X is 0. So I'll take 0, then I look at Y. Well, Y has a 0 as well, so I have the ordered pair 0, 0. Now in the next one, well, we can take 0 from X again, but then we can take 1 from Y. And we can keep doing this. So we try to make every single pair that we possibly can. So for instance, now we can take X as 1, Y as 0, X as 1, Y as 1. Now we can move on to the 2. So now we can have the first element being 2, the second one being 0, and then the first element being 2, and the second being 1. So I think a better way when I first explain this is to line this up like this. X is 0, 1, and 2. Y is 0 and 1. Essentially, we want to make every pairing possible with our ordered pairs. And this is exactly what I've done in the diagram. So I've done 0, 0, 0, 1, 1, 0, 1, 1, 2, 0, and 2, 1. Okay, so what does it look like if instead of taking X cross Y, I take Y cross X? Well, visually in this kind of graph here, it's the same thing except reversed. So now I'm doing 0 with 0, 1, and 2, and then I'm doing 1 with 0, 1, and 2. So essentially, I'm going to get X cross Y, but each pair will be flipped. So I'll still have 0, 0, and then I will have 0, 1, and 0, 2. So this is when Y is equal to 0, then X is 0, 1, or 2. And then we'll do everything starting again when Y is 1. So we'll have 1, 0, 1, 1, and 1, 2. And we can see this is the exact opposite of X cross Y. So 0, 0 is a flip of 0, 0. 0, 1 is a flip of 1, 0. 0, 2 is a flip of 2, 0. Our 1 zeros cross, our 1, 1, and our 2, 1 cross. So, of course, this makes sense because x cross y means first from x, second from y, while y cross x would mean first from y and second from x. So, of course, these would be flipped. So that's the Cartesian product. Now, if we can make the Cartesian product, we can also talk about the size of that Cartesian product. And we have a little thing here that says that if we have A cross B, and the size of A is m, and the size of B is n, then the size of A cross B is just m times n. And we saw this before, because we had x had 0, 1, and 2, so that was 3. Y had 0 and 1, which was 2, and then the size of x cross y was just equal to 3 times 2, which is equal to 6. And this is because each element in x has to pair with each element of y. So, of course, you would have 3 times 2, which is 6. And it doesn't matter how big the set is. If A has size 30 and B has size 20, then A cross B would have 30 times 20 elements in it. Or 30 times 20 ordered pairs in it. Okay, now that's just Cartesian products when we have A cross B. But we can do A cross B cross C. In this case, the first element in our ordered triplet comes from A, our second comes from B, and our third comes from C. But we can generalize even more than that. We can go as many sets as we want. We can make an n-tuple, where the first element comes from A1, the second element from A2, all the way on until the last element comes from AN. So we can have a 6-tuple, a 23-tuple, a 200-tuple. Of course, those are going to get much, much bigger, but it's still possible. So let's do an exercise. Let's let A equal the set AB and B equal the set CD. What is A cross B? Well, A cross B, I have, well, ordered pairs where the first element is from A and the second is from B. So the first element from A, we can take A from A and we can take C from B. We can take A from A and D from B. We can take B from A and C from B. And we can take B from A and we can take D from the set B. So this would be the cross product of A cross B. B squared, what does B squared mean? Well, B squared really just means B cross B. So this means the first element comes from B and the second one comes from B. So we could have C and C, we could have C and D, we could have D and C, and we could have D and D. So it's still the same procedure for building these. Just because it's the same set doesn't mean that we treat it any differently. The first element comes from B and the second element comes from B. You'll still have 4 things in that set. What about the empty set cross A? Well, this is interesting, since if you take the empty set and cross it with anything, you get the empty set back. And this makes sense, right? Because if we have the empty set cross A, this should just be equal to the cardinality of the empty set times the cardinality of A, which in this case would be 0 times 2, which is equal to 0. And of course we know that the cardinality of the empty set is equal to 0, so that is essentially why this holds. And a good way to remember what to do when you think, oh no, what do I do with the empty set? Okay, and one last thing with cardinalities. Let's just assume we have 2 sets. The size of B is m and the size of A is n. Then what is A cross B? What is the size of that? Well, that's going to be n times m, which is just nm. What about the size of A squared? Well, this would just be n times n, which is n squared. So now we can do something really ridiculous, which is what some discrete math professors love to do, and I don't know why, but I guess it's kind of exciting. They can say, well, what is B32 cross A19? Well, okay, so if we look at A squared is just n squared, then B to the 32 is going to be m to the 32, and A to the 19 is going to be n to the 19. So that's how big b to the 32 cross a to the 19 is. In fact, it doesn't even matter what order this is in, because a cross b and b cross a are going to have the same size. It's just the order is different. So this would be something like b cross b cross b cross dot 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 cross b cross a all the way up to the 19th a. But even if we messed around the order, the size would still be the same. So if you have any questions on cardinality or the Cartesian product, let me know in the comments and I'll answer it as best as I can.